Okay, so I am hopefully recording the free responses in the electrical circuit packet. Okay, so we have a 12-volt battery, a resistor, a 2 ohm, a 4 ohm, and they want to know what is the current. Part A wants to know what is the current right there and that resistor R. Well, not a big deal. We know the voltage. Since this line and this line are in parallel with each other, the voltage here is 12, the voltage here is 12. So 12 volts covers 6 ohms of resistance. Because these are in series, I added them to give me an I of 2 amps. They tell me the total current out here is 3 amps. So if 2 amps with the switch closed goes this way, 1 amp is the current through my R right here. Okay, so that's no big deal. Alright, let's scroll on down and see what the next part. Okay, now they want to know, well, what is the value of the unknown resistor R and the heat? Alright, well, let's look at that. So the value of the unknown resistor R, well, we said that it was in a 12-volt line. It had a current of 1 amp, and R is equal to V over I, because I is equal to V over R. So when I rearrange it, R is equal to V over I. So 12 volts over 1 amp tells me that R is 12 ohms. Then they want to know the heat dissipated. Well, heat is energy. Energy is power times time. Electrical power is I squared R. But I can't leave in minutes, I need it in seconds. So I was 1 amp. R was 12 ohms, we decided. And T was 60 seconds. So that's going to give me 720 joules. Because I squared is 1. 1 times 12 is 12. 12 times 60 is 720. Alright, so we took care of that. Now let's just scroll on down and see what... Alright. Oh, goodness. It says okay. So we're going to put in a 6 microfarad parallel capacitor by getting rid of that. Determine the total current in the 4 ohm and 2 ohm and the 4 ohm resistors after the switch has been closed for a long time. Okay, so after the switch has been closed for a long time, that means that, if I can get my little pin to work over here, come on now, wait, there we go. If after a long time, the capacitor is completely full. So no current flows there. Alright, so then really all I have is 12 volts divided by 6 ohms is 2 amps for that line. So I know that the 4 ohm resistor and the 2 ohm resistor, since they're in series, should get 2 amps. So that should not be a big deal. Alright, so I'm going to scroll on down and see what this next little thing asks us to do. How much energy is stored in the capacitor? Well, let's see. We knew it was a 6 microfarad capacitor, and I know that the energy stored in the capacitor, E, is equal to 1/2 CV squared. 1/2 6 microfarad. Voltage is 12. So I know that half of 6 is 3. 3 times 144, because that's what 12 squared is. That's going to be a 12, a 13, a 432 microjoules of energy. Is going to be how much energy is stored in that capacitor. Alright, I'm going to pause, come back and do the second. Okay, the second one says that a student is given 3 identical wires, 5 D cell batteries, a voltmeter, ammeter, and some wires, and she is instructed to complete a circuit using one resistor such that the batteries can be added in series one at a time, in which both the current and voltage can be measured properly. Draw a schematic of the circuit when 2 batteries are connected in series. And so here's what I know if this thing wants to cooperate. So I have a resistor. I want a battery. So there's my 2 batteries in series. And then that's going to be, if each of them are 1.5, so that's going to be 3 volts. And they want me to put in a voltmeter. Voltmeters always go in parallel to the resistors. So there's my voltmeter, and then they want an ammeter. Ammeters always go in series with the resistor. So I've gotten that one done, and it's done correctly. Okay? Alright, so let's see what they want now. Let's scroll on down. Alright, so it says, after completing the circuit with 1 battery, the student measures a voltage and the current for the resistor and then keeps adding batteries one at a time and makes the following measurements. So the voltage increases as it should and the current increases as it should. Then they want us to make a plot and that illustrates a mathematical relationship between voltage and current. Use appropriate graphing techniques. So you're going to draw your labels. You're going to label your axes, and you're going to want to find eventually the resistance. Well, R is equal to V over I, so I want V on the y-axis and I on the x-axis. And if you make R is equal to V over I, and that would get you the slope. Okay. All right. Now when you plot it, and I'm not going to plot it, it could be really hard to do on this board, but when you plot it, you should get the resistance to be 10 ohms or very close to 10 ohms. So I'll write that down for you. Oh, well, maybe I will, maybe I won't. Right now it doesn't want to cooperate. So I do know that it's 10 ohms though, because that's the slope of the line. Alright, so let me see if I can get this thing to where it wants to be happy and work again. So let's scroll on down. Alright. Then it says the student arranges 3 identical resistors and the 5 batteries in the arrangement shows, and so that there is neither series nor parallel. So you have to wind up doing Kirchhoff's laws, and you've got to find I1, I2, and I3. And Lisa and I did that, and we had so much fun, and it took forever. So you won't see that on the AP test, but if you wanted to see what the work should look like. All right. So here's what's going on. This is how they worked it out. And then you can pause and take a look at that. And then they came down and did a little bit more work. And like I said, it's kind of long and convoluted. And they got I1, I2, and I3. So that's what I know on that one.